Hello and welcome! Whether to use disposable alkaline batteries or those new rechargeable lithium-ion batteries, old Nintendo portables are some of the longest lasting game systems that I've personally owned. They can run for multiple PlayStations on a single charge, and they feel like they can go on for days, even after a couple of years worth of use. However, in Nintendo's first attempt to make a hybrid home portable console, that dedication to long-lasting battery life sadly disappeared. And if your Wii U gamepad charger isn't a few inches away from you, your gamepad is going to die and your game sessions are going to be rather short if you don't own a Wii U Pro controller. Which I feel isn't fair to both the Wii U as a system and to the fantastic game library, which I really like to play more of. So today I'm going to do something about it. I am going to buy a new battery for my gamepad and I'm going to make it work, no matter the cost. Today's video is sponsored by 16-Bit Store. At 16-Bit Store, we design and 3D print a variety of items for your video games and consoles. From our styluses to our display stands, we take pride in our designs for all products that we create and the finished quality of our prints. If you are interested or just want to help out the channel, why not visit the 16-Bit Store today? And if you use offer code 16BitReview on Etsy, you'll get 15% off your order when you buy 2 or more items. The reason I want to get a new rechargeable battery for my Wii U's gamepad is because the current battery only lasts between 45 and 50 minutes depending on the game at my desired settings. Now that's not very long when you consider how big some of these games are, especially Breath of the Wild. And I feel a battery replacement is necessary. And normally when I go out to buy a new rechargeable battery for any device, whether it be Nintendo, Sony, or otherwise, I will typically try to get a OEM replacement battery from the device's manufacturer, in this case, Nintendo. But sadly, Nintendo no longer sells these batteries. This is the one that came with my Wii U many years ago. They don't even sell that improved 3000 milliamp hour battery, which I was actually considering for this upgrade. But I'm not completely out of options since there exists the third-party battery. And I know, I've heard that they can be dodgy. Some say that it's even worse, especially for the Wii U, than the battery that you already had. I've heard others say that it's just manufactured landfill. But how can that be when the top rated battery, which I'm looking at, has over 400 reviews with the average rating being 3.5 out of 5? How can it be that bad? Which is why I ordered this replacement Wii U gamepad battery, and I am ready to go and test it out. You know, if this actually works, this will be a very short video. So my replacement battery is now dead, and it sadly didn't live up to my expectations. Color me surprised, but I wouldn't discount buying this battery as a complete waste of money because the battery did work, just not exactly as advertised. Because on paper, the battery does function. It's able to discharge into the gamepad, and I'm able to play any and all games on it without issue. When the battery dies, I'm able to charge it up again from the gamepad's chargers with no issue. The only issue that's here is its at least written capacity, which got me thinking. If the battery is perfectly functional, and the only issue here is the capacity, could I just swap out the lithium-ion battery that's in here with the bigger one and have it work exactly as I would like it to? And the answer to that question is a conditional yes. Now, this video is not a step-by-step guide for how to actually do this, but rather more of a guide to show whether or not it's possible to do this, and if you were going to follow in my footsteps, what you need to consider if you decide to mod your own Wii U gamepad's battery, or by any stretch of the imagination, any other system that has a rechargeable battery that's no longer sold, and the Chinese equivalent is, well, manufactured landfill. So what am I going to need to actually get this done? Well, firstly, I need a Wii U compatible battery plug, and technically charging circuit, which is connected to said plug. And since I already have a replacement battery, which I'm not going to use outside of, well, this video, might as well use the components inside of it for something that I'm actually going to use. Plus, since I'm not destroying my actual Wii U gamepad battery, it means that if I fail, I still have something I can play the Wii U with that I'm okay, or at least satisfied with using. Now, the second thing I'm going to need, and this is crucial, is a replacement battery cell. It is imperative that you buy a battery of the same type as the one which you are replacing, since not all rechargeable batteries have the same charging cycle. A good example of this is if you have a lithium-ion battery, you cannot replace it with a nickel-cadmium battery. Since my battery states that it is a lithium-ion and I see a LiPo inside, I got exactly that. Now, you can buy lithium-ion batteries more or less anywhere, but as I'm recording this in 2021, there's global shipping issues, especially from China, so to make sure that I actually can get the battery that I at least am happy with, I decided to get one locally, and I got this 2,500 milliamp hour battery from Canada Robotics, and it will do the job for me nicely, since the only other battery that they have on offer that's bigger than this wouldn't fit within the gamepad's chassis. I think it was 6,000 milliamp hours. But as a small note, from the reading and research I've done leading up to this video, the largest capacity battery that you can actually fit in the gamepad's chassis is 3,000 milliamp hours. And the Thingiverse user Cocoon42 actually did their own version of this and was able to fit a battery in there perfectly. So if you are intending on maxing out your Wii U gamepad with the biggest battery that you can fit without modifying the battery cover, keep 3,000 milliamp hours in mind, or at least Cocoon42's post about it. I'll have that linked in the description if you want to read it up. And finally, since I am using a larger capacity battery, more than what the original gamepad had, sadly I'm going to need a new battery case, since it's pretty clear that I can't fit this guy into the old shells. So since I have a 3D printer sitting in the wayside and I've designed a fair few 3D models, I've decided to just build from scratch my own case, which is sitting here and I've used a few screws from an old project that I didn't complete, or well, actually I think it was an old broken machine that I had. I will be uploading this model to a bunch of 3D printing STL sites, so if you want to go and print your own case and follow along with me, I don't recommend it. I will have the files available. I also upload an FBX file, so if you want to modify the original design, you can without importing the STLs. And I believe that's everything I need. I just need to grab my soldering station, bring it over here, and I can get started modifying this battery. Wish me luck. Hello, ladies and gentlemen. I am going to be dissecting these batteries. Now, when you're taking apart the Wii U gamepad, I'm actually going to show you the original. When you are taking apart the Wii U gamepad battery, I want to make a point This has a chip about here. There's pictures from the Cocoon 42's Thingiverse post that shows this. But there's a chip here, and all this is battery. So if you are going to disassemble the actual Wii U battery, I'd attack it from the gamepad port, or sorry, the wire port here, instead of going at around here. Because if you puncture the battery, you are going to catch it on fire, because lithium-ion batteries are quite reactive with itself. Or at least other metals. Shorting it's not going to be good. And that's actually what I did when I opened up this guy for the first time. I went in it with a knife. Actually, I think I started from here, and I just started working my way around until I can get enough of a lift on it, and then open it up. But just keep in mind, remember, the Wii U gamepad battery, all of this was battery. This... oh, come on. There we go. This is the one that came with it. The Wii U battery was like right up against the plastic with the circuit board, and all that was filled with battery. Now, I did some measuring and some looking up, and I believe the capacity of this battery is 1,000 milliamp hours. Which explains why this thing does not last. It's a third of the capacity that it promises. So I am going to get it completely out of here. I'm probably going to put it back once I'm done. Here we go. So we got double-sided tape, battery, and circuit. Now, the concern that you might have when going into this, and I've talked to an electrical engineer to make sure that I am right about this, is when you are going into a battery like this, I've been told that you're better off keeping the circuit that came with the battery. The logic being that the circuit that came with the battery is designed to charge the battery that you have, which is all good and fine in theory. However, you'll notice that on the gamepad you have 4 cables. Positive, T, negative, and a unknown, unlabeled. If you look on the back of this where the wires are being placed, you'll see that you have positive, T, and negative, which, I mean, it'll work, but you really needed to figure out what this B was. And I actually sat with my with the engineer. So if you're watching this, hi, Dad. And we analyzed, or at least I went out and did every single pin on this circuit, and we figured out at least how it works. So the little chip here is a DW01A charging IC. Now the way that works with the MOSFET, at least from the wiring diagram, this white cable is plugged into a drain sensor, a drain pin on the 8205A MOSFET, and it's attached to the ground pin on the DW01A chip. So at least from my knowledge on that, it means that white is most likely ground, and I was able to follow white back onto the Wii U motherboard to the 101007 chip on pin 42, which, if the ground pin on this IC is anything to be believed, then that means that white is most likely ground. So I actually looked up the integrated circuit on these. So these both actually have the same DW01A integrated charging circuit. Now that's a good thing, because that means that they both function the same. And if you look at the recommended use case for this charging circuit, the battery is actually a separate element and could potentially be swapped out, which is exactly what I am planning on doing. So I am going to go and desolder this battery by taking my soldering iron and literally just going tink, and come on. Don't want to put the heat on for too long, or else it will not good for battery. So tink tink, that's gone. So now this battery, I don't want it. And what I'm going to do, these are tack welded on. So I'm going to use a tried and tested method for removing these, which is taking a thin sharp thing and prying it off. Don't worry, I'm an untrained professional. I've been doing this technique for Game Boy batteries. Yeah, for the Game Boy batteries. I'd show you my Pokemon Blue, but that's an app. I've replaced the battery at this point. But the way it used to work is I actually would tink these off. I should have. You know what? Where's my marker? I'm going to figure out the. As an aside, one of these is always good, and I need a marker. This is a 3.7 volt battery. I'm going to figure out. And remind myself which one's positive, which one's negative. If I'm wrong, it will be the opposite. So, tink. So positive, you're positive. And on paper, that should work. It's a bit of a mess. But hey, on paper it should work. Now the battery could just be flat. Good. Good news, I didn't fry my gamepad. Bad news, battery didn't work. Positive, 3.8. Yeah. Positive, I can recover from this. Negative, something went wrong. Oh, that'd explain it. That would explain it. The negative terminal popped off. Oh, I thought something broke. Actually, something did break, but I thought something critical broke. My hands are too shaky now. Crap. Gotta get... My hands, they're too shaky. Okay. Show's over. My MOSFETs are getting hot. Time for a call to Dad.
So when you...
I plug it in.
Hey, when it heats up, how hot does it get?
It's hotter than I want to touch it, and it might have been hot enough to desolder one of the pins.
Okay, so be careful there, because if you go back to those data sheets,
yeah,
you'll see how hot they can actually get in Celsius.
Oh yeah, it could just be fine, and it could just be charging.
Well, because you're plugging in a battery for the very first time, right? I suspect it needs to charge it.
I don't... Yeah. Smoke.
Yeah, if it's smoking, it's way too hot.
It's not even charging. I just plugged it into the console.
And how does it get power to start smoking?
My guess is the battery is partially charged. Sorry, the battery has 3.7 volts on it.
Did you put them on the right polarity?
Would it shoot up in temperature like that if it was on the wrong polarity?
Oh, yeah.
Okay. What I did to check the polarity to make sure it was right, I put my black voltmeter on the negative terminal and put my red voltmeter on the positive terminal, and if it was a positive voltage, then it was on the right plane. Did I do that wrong?
No, it sounds all right. It's just, I'm looking at the time. I am so sorry, Andre, but I've got to go.
I just need to figure out if I'm reading this right. So my voltmeter has COM, MA, V...
Yeah, you're common.
COM, which color do I put on the COM? Black or red?
Black.
I had that backwards. Polarity was reversed. Circuit was protecting my system.
Oh, Jesus.
Hey, nothing has broken yet. So what went wrong? Well, when I started this whole thing and I grabbed my voltmeter, I didn't check to see if the red and black wires were plugged into the correct terminals. The last I used it, I was checking for continuity. And as it turns out, they were reversed. So, because my voltmeter was reading backwards, I accidentally reversed the polarities of the battery connecting to the charging circuit, and as a result, the MOSFET shot up in temperature to the point where it was hot enough to desolder the negative terminal connecting to the Wii U. I am absolutely certain that if that battery terminal did not disconnect the battery to the system, it most likely would have caught fire and this whole thing would have been ruined. Or worse, my building would be on fire too. But despite my best attempts to burn down my house, I was able to get my battery to work in the end. And I am delighted to say that it works brilliantly, leagues better than my old battery and my replacement battery combined. Sure, it's not the maximum capacity that you could probably squeeze into your Wii U gamepad, but with around 2 hours of non-stop battery life at my desired max screen brightness settings, it's more than I feel I would ever need for at least a single play session. If I did want more battery life, I could drop the display brightness down a bit, or I can do what everyone else did and just grab my Pro controller. But I'm just happy that I can just use my gamepad again without the fear of a red flashing light every time I pick it up. Now, with all that said, I do not feel comfortable recommending this type of project to absolutely everyone. Unlike, let's say, installing custom firmware on a PSP, where the worst that could possibly happen is your console bricks itself and is no longer functional. As you saw with my simple mistake here, I nearly started a house fire, and I'm just pleased as peaches that it didn't come down to that. And with the help for those around me, I was able to fix the mistake before it got worse. But if you are confident in your soldering skills and know how to actually work a voltmeter, I found the experience to be rather easy and simple to do. Unplug 2 pins, solder 2 more on, and you're good to go. In fact, I feel confident now that I've made my mistakes. I might actually do another project like this in the future for other portable systems or portable-like systems that have similar battery situations. But anyways, thank you ever so much for watching this video. I hope you found it entertaining. I'm now going to play some more Splatoon, and I hope you have yourself a good day, and as always, take care.